Hello, everybody. So now we are going to discuss one important thing regarding the extraction of data from tables, from Steam tables, and this will apply to any tabulated data that you can deal with. In many cases, you will have table like the one that we have here. You have data for the enthalpy for different pressures. And for each pressure, you have data for enthalpy, and you need to find the value of enthalpy uh, uh, by extracting the data from table. But the pressure that you are interested in is 1.43. You would see here that the data that you have is 1.3, 1.4, 1.5, 1.6. So 1.43 is not part of the table. It is in between the data that you have in this table. So in order to get the so there's something that you need to be aware of, that there is a change in enthalpy, which corresponds to the change in pressure. So if for instance you know that the enthalpy at 1.4 bar is 458.4, and at 1.5 is 467.1, then at 1.43 it would be somewhere between these two numbers. It can be 460, it can be 461, 62, 63, or up to 467. So it should be somewhere between these two, and the same applies for the enthalpy of steam. So this is an important point to keep in mind. We said the data that we have is not including this. So to get the data point that you are interested in, we calculate it using a method called linear interpolation. So interpolation is getting a data or calculating data by the knowledge of two data points before and after this data point that you are interested in. That's why it's called interpolation. So interpolation, it's intermediate point between the two points. We will understand why we call it linear. We call it linear because we assume the relation between the enthalpy and the pressure is a linear relation. And we will get into more details later, but just I want to make this point clear that in this case you want to get a data point or the corresponding enthalpy for this pressure using the data before and after. This is called interpolation. So there are different ways of doing interpolation, but the simplest method is called the linear interpolation, which is a good method, and we will check this later, inshallah. So when we do the linear interpolation, this is the same data that we had. We assume a linear relation between the enthalpy and pressure. So just to have a visual understanding of this is the enthalpy on y-axis, this is the pressure on x-axis, and these are the 2 points that we have: 1.4 and 458.4. We have 1.5 and 467.1. So these are the 2 points that we have. So when we say that we are interpolating using the linear interpolation, we assume we know that this is the pressure that we are interested in. So we assume a linear relation, which means that this is a straight line between these 2 points, and the pressure would be or the enthalpy would be the intersection of this pressure and this straight line, which would be 461 or something. And this, since it's a straight line, it has a slope, which is something that we all know, that straight lines have a slope, and this point is going to be the point of intersection. And then we can calculate, we can get it graphically. So we can do this graphically by just drawing the lines, but it's not always a nice idea or a good idea to do the graph, because you need to plot and draw straight lines, and it takes lots of time. So we can do this by doing some calculations. So we can calculate the slope, which is delta y over delta x. We have delta y, which is going to be the change in enthalpy, over delta x, which is the change in temperature between the two known points, which is 1.4 and 1.5. So this is the slope: 467.1 minus 458.4 divided by 1.5 over 1.4. So this slope is valid for any 2 points on this straight line. So we can calculate the slope, and the slope can be calculated using this point and this point. So it's going to be the enthalpy that I don't know, minus 458.4 over 1.43 over 1.4. The slope in both cases is the same, so I can combine the two equations and I can have the linear interpolation equation, which is an equation, let me just zoom in, which is an equation with only one variable, which is the enthalpy, which is this enthalpy, in terms of the two pressures, these two pressures, and these two enthalpies. And of course the pressure of interest, which is 1.43. So this is simply how we do the linear interpolation. So we don't need to draw anything, you just calculate the slope using the two known points and the slope as a function of the unknown enthalpy, and then we can use these two equations together to calculate the enthalpy. So it's very easy and straightforward. So the general equation for it, so what we discussed here is just the general idea how we reach at this point. So when we do the interpolation, we don't need to go through all these. So we need just to apply the equation. Of course, we understand the equation, but we need to know how to use it quickly. So the equation is delta y, which is y, the unknown y, minus y1 over x1. Of course, x is the independent variable that I want to get its corresponding y. So I know 2 points, x1, y1, I know x2, y2, and I know x, and I don't know this y. So it's going to be y minus y1 over x minus x1. This is the slope, which is equal to y2 minus y1 over x2 minus x1, which is the slope. And it can be y2 minus y over x2 minus x. You can combine any 2 points to get the slope. It's valid for any 2 points. So if you rearrange the equation, you can calculate y directly equals y1, which is this y, plus x minus x1 over x2 minus x1 multiplied by y2 minus y1. I personally like to go with this. This sometimes confuses me, so I like to go for this directly. Just the slope delta y over delta x equals delta y over delta x. You have one equation and one unknown, and then you can just calculate it. And as I told you, you can use this equation for the second point, the slope with these 2 points, not these two. So it's again it's valid for any case, and the expressions will all of them will provide or will give the same result. So this is a very common thing that we do. And this, by the way, and this is one point that I forgot to mention. If you go back to the I'm sorry, to this assumption, this assumption is very valid, especially when you have a small change in pressure. So you can assume that you have many points and that the relation between the 2 points is they're very close to each other, so the difference is not that big. So you can assume that the relation between the enthalpy and pressure between these 2 points is a linear relation. So it's a very valid relation for small differences. If it's a big difference, sometimes it's not very accurate, but for these small differences, it is a very good approximation. So anyways, this is what we want to mention here in this example, or in this video. Next time we will solve a couple of questions or problems on the usage of steam table and how to extract data, and on interpolation. So I'll see you then, inshallah. Goodbye.